Welcome to another episode of Science Made Simple. I'm Dr. Ryan, and I'm a science specialist here at the Pique Lab. In this video, I'll be analyzing a past year examination question on the topic of electrochemistry. I have also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. A few drops of litmus solution were added to concentrated rubidium chloride solution, and the resultant solution was electrolyzed using platinum electrodes. Whenever you see these kind of electrolysis questions, the first thing they should always do is to label the anode and cathode. If you look at the cell, we can see that the positive terminal is here, whereas the negative terminal is here. If we follow the circuit, we will be able to see that the electrode connected to the positive end is the positive electrode, whereas the other one is the negative electrode. Which one do you think is the anode? And which one do you think is the cathode? For electrolysis, we have to recall the acronym PANIC. PANIC stands for positive anode, negative is cathode. With this acronym, we will be able to tell that the electrode on the left is the anode, whereas the one on the right is the cathode. Next, let us analyze the electrolyte. For this electrolyte, we are using concentrated rubidium chloride solution, and this can be represented by the chemical formula RbCl aqueous. Rubidium is a group 1 element, and its salts are soluble in water. Therefore, it dissolves in water to give us Rb plus aqueous as well as Cl minus aqueous. Besides this species that is present in this solution, what do you think is another species that is also present in this solution? The answer is water. So, water can undergo self-ionization to produce H plus aqueous as well as OH minus aqueous. If we electrolyze a concentrated rubidium chloride solution, what do you think are the products at anode and cathode? Let us draw a table to help us determine the products at the anode and at the cathode. Do remember the cathode attracts cations, and in this solution we have two cations, rubidium plus as well as H plus cations. So these two cations will migrate to the cathode. On the other hand, the anode attracts anions, and there are two anions in concentrated rubidium chloride solution. They are Cl minus and OH minus anions. So these two anions will migrate to the anode. What do you think are the type of reactions that's happening at the cathode and anode? Can you still remember the acronym REDCat and OX? If you can recall this acronym, you will be able to identify that reduction is happening at the cathode, whereas oxidation is happening at the anode. And we have learned in the chapter of redox that reduction is the gain of electrons, whereas oxidation is the losing of electrons. For this electrolysis, it's also important to note that we are using platinum electrodes. Platinum is an inert metal, so itself doesn't react in the electrolysis reaction. Hence, this actually simplifies our analysis. Let us now analyze what is happening at the cathode. Although we have Rb plus and H plus that will migrate to the cathode, only one of these ions will be selectively reduced. And we will have to rely on the reactivity series in order to determine which one will be selectively reduced. You may pause the video now and try to recall the reactivity series. So, this is our reactivity series, and we can see hydrogen here. Can you spot rubidium in this reactivity series? The answer is no. We have not learned about rubidium's position in the reactivity series. However, like what we have analyzed just now, rubidium is a group 1 metal, and we have learned that for group 1 metals, reactivity increases down the group. If you analyze the position of potassium and rubidium, you will be able to see that rubidium is in fact even more reactive than the most reactive metal in the reactivity series. Therefore, we can place rubidium at the top. And in fact, we will be able to see that rubidium is way more reactive than hydrogen. With respect to the reactivity series, hydrogen, which is below rubidium, will be preferentially discharged. Let us now analyze what is happening at the anode. Similarly for the anode, we have two anions. However, only one will be selectively oxidized. Which of these do you think it will be? We have learned that for a diluted aqueous solution, the hydroxide
OH- anion will be preferentially oxidized. However, for concentrated halide solutions, such as chloride, bromide, or even iodide, the halide anion will be preferentially oxidized. For this case, the chloride anion, which is present in concentrated solutions, will be preferentially oxidized. Now, take a few seconds and try to work out the equation for the reaction that is happening at the cathode as well as the anode. At the cathode, H plus gains electrons and is reduced to form H2 gas, whereas at the anode, chloride ions lose electrons, itself is oxidized to form chlorine gas. If you look at the options given, option 1 says a greenish yellow gas is formed at the cathode. If we analyze the reactions at the cathode and anode, we will see that hydrogen gas is produced at the cathode. Hydrogen gas itself is colorless, whereas chlorine gas, which is produced at the anode, is greenish yellow. Hence, we can see that this greenish yellow gas should be produced at the anode instead of the cathode. And this makes option 1 incorrect. Option 2 says the anode decreases in mass. However, in this electrolysis setup, we are using platinum electrodes, and we have learned that platinum electrodes do not react in electrolysis. Therefore, we do not expect any changes in mass to both the anode and cathode. So option 2 is also incorrect. Option 3 says that the pH of the electrolyte decreases. Let us try to analyze what this option is trying to say. We have learned in acids and bases, if pH decreases, this implies that the solution is becoming more acidic, which also implies that there is a higher concentration of H plus ions, and vice versa when the pH increases. If we analyze the reaction that is happening at the cathode, we can see that H plus ions will combine with electrons and become hydrogen gas. So this is as good as saying that the amount of H plus ions in the solution will decrease. Since the amount of H plus ions decrease, we will expect the solution to be less acidic, which will result in an increase in pH. Therefore, it is obvious that option 3 is also incorrect. Option 4 says the solution turns blue around the cathode. And if you look at the question, there is something that we have not yet analyzed, and that is the litmus solution. Can you still remember the color change for litmus solution? Under acidic conditions, or when the concentration of H plus is high, it will be red. Whereas under alkaline conditions, or when the concentration of H plus is low, it will be blue. Let us go back to the equation at the cathode. Just now, we have already determined that the concentration of H plus at the cathode will decrease. Hence, we will expect the solution around the cathode to be more alkaline. Therefore, we expect the litmus solution to turn into blue color. Therefore, option 4 is the correct answer. Before we end off, let us also look at what color change do we expect to see at the anode. If you look at what is produced at the anode, you will notice that we have chlorine gas. Chlorine gas reacts with water to form hydrochloric acid as well as hypochlorous acid. Since we are producing two acids, we expect to see the solution turning red based on the concept that we have learned just now. However, that is not all. The hypochlorous acid that is produced is a component of bleach. So, what will happen is that after this solution turns red, it will be bleached into a colorless solution. Quite an interesting color change, isn't it?
Thank you for watching, and I hope you have enjoyed this video. If you found this video useful, do give us a thumbs up. If you'd like to check out more videos by us, do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you next time. Bye!